Hey, let's take a look at the standard deviation for a sample. And although we seem to spend most of our time on populations in Chapter 4, I really want to revert to samples now that I always list in red, because SPSS treats everything as a sample by default. They always go the n-1 route. Let's take this particular array of numbers. This was an easy array. It had a mean of 4, so the sum of x was 16. You could calculate the sum of squares this way, and arrive at that 46. So you'll remember that we squared each value and then took the sum of the values and squared it to get our sum of squares formula. Or you could do it the basic way, what I call the definitional way that I think is easier when you have a rounded mean, and subtract 4 from each number. Get the sum of all those subtractions, or the sum of all those deviations, which we know will always be 0. And so therefore we have to square the deviations and add the sum of those square deviations, which has the nickname of sum of squares. Hey, cool. And sure enough, it came out to 46 either way. And then we would calculate the variance, which is the sum of squares divided by n-1 for a sample. Remember, it was divided by capital N for a population that was always listed in black. And then, of course, I just need to take the square root of 15.33 to get the standard deviation of what was it, 3.92. So let me go do the same process in SPSS, and excuse me, I'm bouncing around here. I've got the same numbers, 8, 6, 3, and -1. Will SPSS faithfully reproduce that number and give me the variance and everything else? Well, sure. Let's do that. So I'll go to Analyze, Descriptive Statistics, Descriptives, and then I'll get rid of these, which I think are not here anymore. Yes, here we go. And I want to put the first one in there, sample 1 with a mean of 4, which this had, 16 over 4. And I'll go ahead and go to the options. I want to get both the standard deviation and the variance. I want to list both those things. And click OK. I'd like to see both of them, please. And hopefully it's going to be precisely the same as we just saw. And let's see. And in fact, let me, again, there's something I just cannot remember to do, is clean the output screen. Analyze, Descriptives, and then Descriptives. Again, I'm producing both the standard deviation and the variance. And click OK. And sure enough, it's exactly the same. SPSS undergoes the same process behind the scenes, if you will. Here's 15.33 versus our 3.92 that we got by rounding, the square root of 15.33. So that's nice. That's pretty cool. Another thing you can look at is, let's go over here and take a different array of numbers. This is sample 2 with a mean of 4. Now, what do you notice about these numbers? Instead of 8, 6, 3, and -1, which has a pretty good range of either 9 or 10, depending on how you think of the range, a fairly big range. This one has a tight range, only from 5 to 3, or from 5.5 to 2.5 if you prefer. So in this case, what would we expect of the standard deviation? Now remember what the standard deviation is gauging. The standard deviation is gauging how spread the numbers are. So wouldn't I expect a markedly lower standard deviation here for sample 2, mean 4, even though the mean is 4? 5 plus 5 plus 3 plus 3 is 16 divided by 4 is 4. Has the same mean and standard mean, but let's see if it has the same standard deviation, and I suspect it'll be a lot smaller. So what I can do for the sake of efficiency is go Descriptive Statistics, Descriptives, and let me do both at the same time, if you don't mind, and watch what will happen. They'll both have a mean of 4, but the second sample will be markedly more tight in the standard deviation, and sure enough it is. Look, the variance is only 1.33, and the standard deviation is 1.15. It's a fraction of the other one, suggesting the numbers are less spread. So it's a good gross toe in the water for how spread out numbers are. Now this is more valuable when you have large array of numbers. So for instance, if we were dealing with the student ages at SFA or something like that, we might find that the mean age is something with a standard deviation that tells a nice story. But another point I really want to leave you with is that the process that we're undergoing is precisely the same in SPSS as we do by hand. It has a way of calculating the sum of squares the variance, which we produced at 15.33, and that standard deviation for any given array of numbers. But by default, it divides by n minus 1 because it treats everything as a sample.